many MOSFETs would you guess are in your average car these days? Well, all right, that is a bit of a trick question. Are we talking about a combustion engine car or an EV? Well, today's gas cars normally contain around 90 power MOSFETs. EVs have way more, sometimes ranging up to 400. And you know what? This number is going up, maybe increasing by 40% in the next couple years. And it's not just automotive designs that are taking advantage of the newest innovation in MOSFET technology. We're also seeing a big increase of MOSFETs in e mobility designs, forklifts, and more. But where can you find more information about this MOSFET innovation? Right here, my friends. Right here. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Joseph Sara from Infinian and I explore the mega trends motivating MOSFET innovation and the details of Infinian's cutting edge MOSFET solutions. We also explore the benefits of Infineon's OptiMOS 7 platform and how you can take advantage of Infinian MOSFETs for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Joseph. Thank you so much for joining me.
Yes, hi, how are you?
I'm good. How are you?
I'm doing great. Thank you for having me.
Excellent. All right. So, Joseph, we're talking about automotive MOSFETs today. But before we dig into the details, MOSFETs can be used for a wide variety of applications within a vehicle, right?
Yeah, absolutely. So automotive MOSFETs are all over the vehicle. So if you look at exterior, interior of the vehicle, they're everywhere. So, you look at sub applications like powertrain, which is basically anywhere between engine, transmission, battery management, or chassis, which, braking, steering system, or anything that's body electronics in the vehicle that has some kind of motor or an actuator utilizes MOSFETs. So they're really everywhere in the vehicle. In fact, this year, in a standard ICE engine vehicle, we're about 123 MOSFETs per vehicle. And on mild hybrid vehicle, about 180 per vehicle. And we average about 130 MOSFETs per vehicle in today's market. And that number is projected to double over the next 5 years per vehicle. So there's a lot of, exciting opportunities there for MOSFETs.
Absolutely. Now, Joseph, what do you think is driving the growth for these kinds of designs?
Couple of things. So a lot of it is really driven by digitalization and decarbonization. So if you look at, some of the mega trends in the world, CO2 reduction. So a lot of the shift into electrification driven either by legislations around the world or by really just electrification of the vehicle going, from ICE engine to either a mild hybrid or a plug-in to a full electric vehicle is driving that content. So applications like battery management or utilizing 48 volt in the vehicle is, demanding more MOSFETs in the vehicle. The other thing in terms of digitalization is, the advanced safety of the vehicle and the passenger comfort. Both of these topics are driving MOSFETs demand. So, in terms of safety, when you were talking about autonomous driving systems, there's a lot of redundancy in those systems and driving the number of content of electronics overall. But surely MOSFETs are impacted by an increased number of demand on them. And when we talk about passenger comfort, nowadays, once you get that premium package in the vehicle, generally speaking, passengers don't want to go back to not having those. For example, if you have a car with a heated seat or a ventilated seat, generally speaking, those are kind of cool to have, right? So all those, having those features in there in the vehicle from a comfort standpoint, lift gate, etc., and we'll talk more about applications, use cases, are driving content for MOSFETs.
What sets Infineon apart from the rest of the pack when it comes to these kinds of designs?
Yeah, so we're a little bit unique in terms of defining our portfolio. So we actually do our requirement pretty comprehensively with application use cases in mind. So we work with our customers and OEMs to find what the requirements are for the application to build our portfolio. So, we've been doing this for over 40 years now. So we have a lot of experience there in terms of development of our MOSFETs and roadmaps and how we do it. The other thing is Infineon takes quality very seriously. We'll talk a little bit more about this on the later slide, but when it comes to qualification, the automotive MOSFETs are generally qualified to AEC-Q 100. Infineon takes it beyond that. We take it seriously that we have a harsher qualification criteria that we have to meet internally, and the industry knows Infineon for its quality. As well, we're committed to having a zero defect strategy. So, we go on and beyond certain testing. And again, the application use case is always in mind when it comes to our MOSFETs and having a production liability and checks, etc., in our process.
Joseph, automotive quality standards are notoriously difficult to achieve and sustain. So, how is Infineon meeting these standards?
If you look at this graph, the bathtub curve kind of shows you the standard industry consumer products versus the standard automotive. You can kind of see then the Infineon graph of how Infineon, goes on in terms of extended stress testing and beyond the AEC-Q 100 in terms of qualification testing. But really, the reason behind it, we don't feel it's enough to meet the true application requirements in the industry just to do the standard AEC-Q 100. So as a result, our internal requirement that we set forth are harsher than the industry standards. But, that's kind of what been driving Infineon's success for our technologies, and MOSFETs are no exceptions. And it definitely gives the customer a peace of mind there to use a product that has been qualified and tested with a longer requirement sets, if you will. Yeah, so in terms of where Infineon, I mentioned earlier, I've been doing this for about 40 years of experience doing this. So you can kind of see over the years on generations of MOSFETs. So, we focus more about OptiMOS 7 here today. But if you look, this is what we still have in production, and some products are ending life, but we've had a long history of different generations, years of improvements, enhancement, meeting new requirements in the industry, etc. So we'll focus more today on OptiMOS 7.
Fantastic. Well, let's dive deeper into the OptiMOS 7 platform. What benefits does this solution bring to the table?
Brings a couple of key benefits. One notable one, it's a 25% reduction in RDSN compared to our OptiMOS 6 that was available in 40 volt, and 40% reduction to our OptiMOS 5, which was available in 80 and 100 volt technologies. So as I mentioned earlier, we've been doing this, over the years. This is actually our fifth generation of trench technology for MOSFETs. Some advantages as well as the faster switching reduction. That's basically for switching application. It's reduction of switching losses.
Joseph, let's dive deeper into the OptiMOS 7 platform. What benefits does this solution bring to the table?
So OptiMOS 7 brings in a 25% reduction in RDSon in the family compared to our OptiMOS 6 family in the 40 volt, and 40% RDSon reduction versus the OptiMOS 5 family in the 80 and the 100 volt. Also has an improved avalanche capability for higher current requirement application. It also has a faster switching reduction for switching losses, so that, for applications that are switching at higher speed or even, normal speed really, but it just, from the optimization of the design, OptiMOS 7 has a lot of improvement to offer to the application level. And it's also our fifth generation of our trench technology. Again, as mentioned earlier, we've been doing this for a few years, and we've had a lot of learnings from over the years.
Fantastic. Now, Infineon is also offering a host of new packages for the OptiMOS family, right?
Yeah, absolutely. So we have now a large selection of leadless packages, and we have a couple leaded packages, and we also now have new packagings that we're calling topside cooling TSC packages. So, with the OptiMOS 7 across the board, packages will all have the option with an OptiMOS 7 product inside them, just about. And we'll talk a little bit more about the packagings versus, different voltage classes, but you can kind of see that we have development anywhere between 40 and even at higher voltages to 120 and 50. Some of those, higher voltages might be in the OptiMOS 6 or 5 technology steps still, but we're still developing, new products in those technologies as well.
So, Joseph, let's talk specifically about the 40-volt MOSFET family. What kind of package options do we have in this case?
Yeah, there's a few here. So we have, packages as small as a 3 by 3, which is we call S308. And then you can go into a package that's more of like a toll package all the way up to a 10 by 12 package. You can kind of see in the middle, there's a few packages that are in a 5 by 6 millimeter packaging. And then for a higher current leadless package, the STOLL are one of our more popular ones. Of course, the 12 by 10 can also do a lot of the applications that require higher current. And then, on the right-hand side over here, you can kind of see we have some of the leaded packages. So we have the SS04G and the Mini Toll G package. So those are relatively newer to us. Those are for certain application or customers that are still requiring more of having a leaded package. But the one that we'll talk about more a little bit that I like a lot is the topside cooling. So there's some advantages to that package, allowing heat, for example, to exit the part from the top rather than through the PCB, if you will. All these packages have some advantages and for different use cases, and we'll talk more about each one of them here.
Fantastic. Well, let's dive into each of these in a little bit more depth. So, let's start with the S308. Talk to me more about that one.
Yeah, our S308 package is a 3 by 3, 3.3 by 3.3 package, available in a few different variants of RDSons. So, of course, the lower the RDSon, the more current capable the device is. And we have these available in non-logic and a logic level switching capability. So, compared to our previous generation, on this package, we have about a 50% reduction in RDSon, which is kind of great. Where these packages are generally used in an application when you have kind of a tight space and where the PCB slash the module is going in the vehicle. So, if you think about it like a power lift gate, right? So you have your lift gate in the SUV or vehicle, right? Or a window lift, it's a pretty tight space where you're fitting a board with a motor inside. And these packages kind of, able to provide enough to power a motor and those kind of application in a tight space. Using multiple of these on the board can kind of streamline the size of the board and still achieve, a good amount of current through them.
So, what about the SS08?
So the SS08 family is actually our largest in terms of available options today. The family actually has some of the industry lowest RDS on available. We have a 0.42 in our logic level and 0.44 that is a non-logic level. And again, those are the industry lowest right now in terms of this package. But the family is very scalable, all the way up to 3.04 milliohms. So this package is one of the more popular one, if you will, in terms of leadless packages across the industry. And it goes into various different applications. It also allows customers to have different scalability in their design, especially if they are using the same design and, same vehicle, but different packaging or trims, if you will, that has different motor currents, etc. So it allows them to populate or depopulate different products and different RDSons using a very sizable, scalable family of products. But, we see customers using these in motor control and power distribution and zonal architecture. So as some of these mega trends that we mentioned earlier, in terms of electrification and decarbonization are driving some of these, content of having more of these products in them. And they're an easy way to use multiple of these in parallel. The package allows you to kind of have a more accessible way to do the layout and have in parallel products in them as well.
So, I believe you mentioned the Mini Toll G solution as well. So, talk to me about that one.
Yeah, so this is a new package for us, and we do this one in a copper clip as well, just like the rest of the our portfolio. And we have right now 4 products available. It's as low as 0.5 million products, and they're all in non-logic level. And a few years ago, the industry went into a lot of leadless packages, and some customers said, "Okay, we'll still need leaded packages." So, okay, we developed a package to kind of meet the JTEC standard for this product. It's an 8 by 8 package. still achieves a lot of the great requirements that our other products like an SSO8 can do, and can handle quite a bit of a current as well. When you look at application use cases, some of the applications, including braking, power steering, battery disconnect, that allows to do a little bit more higher current than just an SSO8 package can do. So there's some advantages there in terms of applications. Certainly customer requirements sometimes dictates that they need a leaded visible inspection, for example, on a leaded package, and this product can offer that for them.
So, what about the STOLL solution? What does this solution help with?
Yeah, so the STOLL package is available in a 7 by 8 and it's a package, again, that allows more current through the part. As the package gets bigger, you can have a larger FET inside, if you will. The advantages of this package, it has a lower impedance to junction, roughly 40% lower compared to the SSO8 package. And RJ theta as well on there is 15% lower compared to an SSO8. So what does that really mean? It gives you a more robust current that can go through the package. Also has an improved thermal performance, sinking basically the heat from the package to the board, right? So it provides some benefits there. The other thing with that is also that in terms of switching, because the larger size of the package, the larger die, if you will, can go inside the product. It has a more of a safe switching capabilities for higher currents. So this is kind of more of a robust capability when it comes to avalanche events in the vehicle. So let's talk a little bit more about the selections and the STOLL package. So the 40-volt STOLL package right now has 5 products in there. As I mentioned, it allows for the higher current. So when you look at some of these applications like power steering, braking, DC to DC, now you can let more current through the parts. So that's really one of the biggest advantages of using a bigger package. It gives you higher power density, if you will, through a 7 by 8 package. And of course, given these are more for a power-driven application, they're only available in non-logic level product. It's kind of amazing what we can do nowadays with the RDSN that goes into these packages. We're talking about a part that has an option 0.39 milliohm product.
All right. So, I believe you mentioned the SSOT10 TSC as well. So, what kind of benefits are we talking about here?
So this package is basically a top side cooling package. So the biggest advantage is a direct cooling path to a heat sink from the top of the part rather than from the underneath the part. So you have an improved impedance and resistance Z theta and R theta cooling of the device because the heat is now leaving the part from the top to a heat sink. The other advantage doing that is now you have more space on your board, if you will, from a PCB area in terms of layout, because now you can, have component on the opposite side of the board. You can now have, different layout strategy, if you will, because now you're not actually, sinking the heat through the board and heating up the board. You're letting the heat exit the part from the top to a heat sink. So that's kind of one of the big advantages here. So, with the package this size, you can have the higher power density. You can still do quite a bit of a current. It's great for application that requires higher currents as well. From an optimization of heat, this is a great solution to keep the PCB size, if you will, kind of smaller and optimizing the PCB layout design. The way we'd kind of done some calculations on this, and we believe this would actually provide cost saving to our customers, in terms of real estate of the board, if you will.
So, Joseph, what other options in this family include topside cooling?
The SSO10 is the topside cooling part that has basically right now 4 products in the 40 volt. We have an RDSN of 0.7 milliohm all the way up to 1.73 in non-logic level. The product is very capable in terms of, current capabilities. You can utilize this product in multiple applications. So like, if you're doing braking, electric power steering, or DC to DC, some of this application that can see a lot more current draw in them, it can optimize that layout and space where these motors or, modules go into the vehicle, and you can have the heat exit out from the top of the part and optimize the overall space. Right now we have 4 options. We're looking to add more to the family.
So, what about solutions for body applications or motor drives? What solution would you suggest in this case?
Yeah, one of my favorite packages that we have is an SSO8 package that is a 5x6 package that is a little bit unique. It's what we call a half bridge. It has the source and the drain connected internally in the part that allows for the customer, if they're doing, for example, a BLDC, a three-phase motor, drop three of these, or if they're doing a half bridge, only two of these, and connect their motor in small amount of space versus if they were to do this with two FETs or a dual die SSOA, they would have a connection going around the MOSFET, if you will, on the board. Provides that benefit. The additional benefit also in terms of EMC testing and requirements, there's additional benefits there because the impedance between the source and the drainage is internally connected to the part rather than having a longer routed traces on the board. So the family today has about 6 parts in them. They're available on logic level and non-logic level, 3 milliohm all the way up to 7 milliohm product for motor actuator kind of products and applications, I should say. It provides an advantage in terms of EMC system performance, and it provides an advantage in terms of switching capabilities, in terms of power losses, and also from a footprint or a layout space, if you will. Any application that has a actuator or a motor can utilize a product like this in a half bridge configuration. They can also use this in a BLDC motor, etc.
Can we also chat about the 80-volt MOSFET options as well? What kind of applications are we talking about here?
Yeah, so the 80 volt and I would say even our 100 volt, they kind of fit in the same bucket of application for the most part. I mean, there's some unique requirements out there that maybe shifts the customer to 100 only. So it's kind of similar to the megatrends, if you will. So the powertrain and the safety application, a lot of those, over the years have been boosted to use higher voltages in the vehicle, so requiring higher voltage MOSFETs. But on the body side, we see more and more OEMs driving towards 48 volt systems, which requires them to use 80 volt and in some cases 100 volt technologies, depends on how they do their vehicle architecture. So let's walk through it. So like in powertrains, you have belt starter generators, generally those are 48 volt. You have traction inverters, they take a vehicle voltage, especially like on EVs, they're 400 or 800 and they're stepping it down and they usually, around 48 volt system and they utilize a lot of MOSFETs. And then, you have motors, actuators, pumps, etc. They're using 48 volt system there to power various things in the vehicle. For example, an engine cooling or a thermal cooling for the battery management system. We see a lot of those today are on the 48 volt systems in the vehicle requiring 80 or 100 volt technology. In terms of safety, for years, electric power steering and braking been looking at using a higher voltage. Higher voltage for some of these systems allows for the cabling in the vehicle, if you will, to be reduced, weight reduction more or less, and space reduction, putting, larger cables, etc., right? From that aspect, the higher voltage, lower current, a lot of those, safety systems, what is happening is they're now redundant. So that space becomes kind of a key because you still want to keep them relatively small where they fit in the vehicle. And then the body application, more of like stuff that are the consumer comfort, if we will, what we call them, right? Like the wireless charging or different motors, inside the vehicle, right? Or even LED lighting in the vehicle, right? They're driving some of those requirements to be in the 80 and 100 volt technologies for MOSFETs.
So, Joseph, what specific benefits and advantages are we talking about for these MOSFETs?
Yeah, so some of the features of this family, right? So you have the low RDSon, which gives you a minimized conduction losses, right? Then you have, stuff like faster switching for turn on, turn off, avalanche capabilities, safe operating area robustness. Some of these features this products offer, allows you to have more superior switching capability, higher power performance. You can have more power density through these products, right? This is kind of what makes it more the features, and then you have the benefit here listed to be more of what are the advantages to the user, right? So let's talk more about here the advantages. So some of the advantages, the lower the RDSon, the more current you can have in the real state of the part. So that's kind of a key in terms of the customer's need. The other, it's in the form factor of what the overall system of that looks like, right? So some of the application where these go in might actually require to utilize more than one product, if you will, on the board, which it's paralleling, where we call it's just having a parallel placement of these MOSFETs to be able to perform a specific current requirement in the application. So having that low RDSon family, it allows you now to utilize less components on the one output, if you will, of paralleling products. So there's some advantage in terms of real estate there.
All right. So, can you give us a rundown on the packages for these 80-volt solutions?
Yeah, so our 80-volt products are, some of these packages we already kind of saw earlier. So there are S308s are available in that, SSO8, STOLL, and TOLL. Those are all going to be available in the leadless family. We also have a dual gate option. We won't talk a little more about this here today, but we have some stuff on this on our website, about the dual gate toll package. But the exciting side is we have now the top side cooling. So I mentioned earlier the SSO 10T product. So we have that also available in the 80-volt technology. We also have a tolled package. The tolled package has been around for quite a bit of time. It's a large package. It's a 10 by 15 package that we have, but it's a great family that we have for customer to select from, depending on what application they're using these products in.
Great. Now, what about Infineon's 100-volt options here? Can we take a closer look at those?
Yeah, so for a 100-volt, we have those available in S308, SSO8, STOLL, and TOLL. And again, in topside cooling, we're investing a lot in the SSO10T product. And we will have products, coming in that package as well for topside cooling. And the TOLL package, we've had that available again for years. We have OptiMOS, 5 and 7 available. The OptiMOS 7 family, as I mentioned earlier, is new and continues releasing more products into that family.
So, can we also take a closer look at that 100-volt SSO8 as well?
Right now, we have 4 parts released in the SSO8 100-volt. There are more parts to come in that family. The lowest option we have right now is a 2.1 milliohm. It goes up to 18 milliohm, and you can kind of imagine there's a big gap in between that we will fill in products that will come soon. But the one thing is, you look at the application example I have listed below, there's many, many applications that could be used here for this package. Once you step into the 48-volt system, as mentioned earlier, right? So some customers require 80 volts, some of them are 100, depending on what application they go into the vehicle. They might have, reasoning to use a higher voltage package requirement for the product. So our family allows them to do that. The one thing I probably should have mentioned earlier, the CAV market, so that's the construction agricultural vehicle market, more like, let's say, the trucking market, etc. That market has historically been a 24-volt market, and a lot of the system now use 24. Some customers we see using 48, so they use a lot of our 80 and 100-volt technologies. And generally, if they're still on ICE-based powertrain, they're using a lot more of 100 volts. So this family, provides great options for them for many, many applications. So I mentioned the CAV market, but other markets, so like more of the mobility, if you think of light electric vehicles, so here we're calling them e-scooters, but could be a e-bike or any transportation vehicle, if you will, that's a two-wheeler, etc., three-wheeler will fit into that. So some of those, we see customers are using 48 volts. We see some using 96 volt. One good example, if you look at forklifts, a lot of the forklifts manufacturers around the world use 72 volt, 96 volt technology or output in their vehicles, if you will, and they require higher voltage MOSFETs. And in vehicle, audio amplifiers, it's another great example, is they boost the voltage quite a bit, which requires them to use more of a higher class voltage MOSFETs.
All right. So, what about MOSFETs over 100 volts?
Yeah, so Infineon has quite a bit of products that are already on the market that are 120 volt all the way up to 300 volt for automotive. But, we now have a refreshed subfamily in the OptiMOS 6 that is in 120, 150 volt. That family now is available in multiple packaging. So we have the Toll G, and the Toll package. We'll have more into this family. So what this family allows, again, is broader voltage class requirements. When you have customers using 60, 72, 96 volt, to have an option to use an automotive grade qualified product in their applications. Light electric vehicle, DC to DC, battery disconnects, we see quite a bit of that. So far we have 3 products in the family, and we will have more in the coming months. So we have products, as low as a 1.7, 1.8 milliohm already, which is kind of great for, compared to some of our legacy products that we've had on the market.
Joseph, if my audience wants a bit more help with these automotive MOSFETs, what kind of help can Infineon offer?
And we have quite a bit of training videos that are posted online that anyone can go in and watch. So if you go to Infineon.com/automotive MOSFETs, we have videos that are specific to specific packagings. We have video just to kind of understanding our data sheets. So, one of the videos we have is called Understanding Automotive MOSFET Data Sheets, right? So it kind of breaks down some of the characteristics that are listed in the data sheet and how to read them. We also have, videos that are more unique into applications as well. So like we have one that is intended for, MOSFET in 48 volt system. What does that really mean? We have one that only talks about OptiMOS 7 and 40 volt, right? Those are really great videos. And as I mentioned, when we talked about Infinian quality, we do everything kind of an application set requirement to better meet our customers' requirement and OEM's requirement. So we even have videos that are specific to discussing applications. So, for example, we have one that's specifically talking about emerging DC to DC conversion applications and how MOSFET topologies fits in. Another one I mentioned quite a bit throughout the presentation about parallel MOSFETs. So a lot of customers ask us questions about that. So we made a video, it's a 15-minute video that anyone can go on the web and watch and learn more on how to do parallel MOSFETs. And then we have videos that are specific to packages. So some of these packages, we didn't go into details here about today, but if somebody wants to learn more specific about these packagings, we have those videos that can be watched online.
Fantastic. Well, Joseph, I think that's all I have time for today. Thank you so much for joining me.
Thank you for having me.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infinian. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.